Hello, everyone. You had a great lunch? Okay, this was the positive part. Now we come to the negative part. Yeah, we are talking about the failed start in Germany. I think I could just use every claim on top and hold the talk every year. But now we are talking about SSI on blockchain. Yes, exactly. What will you have in the next half an hour? First of all, I will just describe what is SSI. When you have been to Adrian's talk in the morning, you should be already have some knowledge about it. Then we will look at, okay, what do we need really from the technical perspective? And then we look what has Germany done with these requirements and what are the learnings you can take at home for your projects. And then we have some Q&A. Yes, some facts about me. I founded a startup 3 years ago where we decided, okay, let's program an own blockchain without cryptocurrency for the SSI problems. Exactly. Code is open source. If you want, just ask me. It's on GitHub. And what do I love? Yes, blockchain, security, coffee, of course, and as I mentioned, open source, working in different communities. Okay, what is open source? Normally, we could just use Google or Facebook, having all our data. And SSI is the short form for self-sovereign identity. So you are controlling your data. You decide who will receive the data. Quite simple. And there's the trust angle, you know. So you have normally the issuer. Let's say, okay, about you, gave you a ticket. It's on your smartphone, on your wallet. It could be a PDF, some kind of digital data, but on your smartphone. And you are presenting it here at the cinema at the entrance. And the people can validate is the credential you are presenting them correct by digital signatures and so on. And they let you in because they are trusting the issuer. So, but mostly, or in most cases, the verifier doesn't really know the issuer. It could be somebody else, and you are not standing next to him that you can ask him, so you need some kind of resource that you can use to query all the information. And for this, we are using a verifiable data registry. In case of digital signatures, we use a PKI as a public key infrastructure. Nothing new, no buzzword. We use it already in the industry for the last 40 years or so. And this registry that is public available to everyone can be used to validate all the information by a verifier that was issued by an issuer. And we are putting different resources in the registry. For example, as I mentioned, I need public keys to verify signature. No handwritten signature, cryptographic signatures. So I need these kind of identities. Then, in some cases, it's interesting that I have machine-readable data. Sometimes I can use PDFs, but I cannot process PDFs automatically, and it would be really cool when it's machine-readable. It can all be processed by our systems. Sometimes it's also interesting that when I'm giving out a certificate, that I am able to revoke it. In the real world right now, when you have a driver license and you have collected too much points, the police is coming, getting your plastic card. Well, it's very difficult when you have the driver license as a digital one. You have multiple copies, and they have to collect all your hard drivers, all the possible devices where you could have this copy. So there are mechanisms like a registry where you can revoke credentials that were given out. And of course, in the case for authorization, because nobody will stop you to put your signature on any document, for example, for a COVID pass. So we have to prove that you were authorized to sign the document. All right, and now the biggest question is, do I need blockchain for this? It sounds good for the people out there, and when we are looking at the Hyperledger stack, here comes blockchain into place. So normally you have our application. Adrian showed us the Lizzy wallet, and this is the technical stack behind it. And the interesting part is here in the green box, where we say, okay, you have a driver that is interacting with the verifiable data, the registry. It could be a blockchain, a DLT, a normal web server, DNS, just some kind of storage that I can query to get the resources. Nothing special. And now they have the question, shall I use a blockchain for this? Pro is, for example, I have no single point of failure because all the data are redundant, and when some node is falling down or acting malicious, I have recovery and backup. I'm also privacy friendly because compared to cryptocurrency and NFTs, I'm not storing the credentials on the blockchain because these are personal credentials, and these personal credentials are shared peer-to-peer from the holder to the verifier. Okay, and I'm interoperable because I have standards like from the Decentralized Identity Foundation, DITCOM, OpenID Connect, so I'm not faster to one technology stack. Okay, what are the cons? Yeah. 3 years ago, Germany thought, well, we haven't made so good with the internet, we slapped it, let's use blockchain just for everything. And here the joy begins. 2 years ago, we had the pandemic, and then the government said, okay, we need a digital person because we had the yellow card, and they said, well, it's okay, but it's not very friendly because you can fake it easily, and we need a digital solution. And then they said, okay, let's use blockchain. And then they showed, okay, how do they want to implement it? On the left, we see the normal the normal scheme we saw earlier, so it's okay. And on the right, we see the implementation that they say, okay, I have a citizen that gets vaccinated, and when he gets a credential, he can present it on a smartphone, and some kind of verifier can verify it. And then they said, okay, I'm storing all the information in a database we are using, and we are using the blockchain as a trust anchor, because a blockchain cannot forget. So everything I put in there has to be in there, and this is the trust part. So this is okay. Now a question for you. How many blockchains do I need to be secure? Okay, who's 7? One more guess. The 7 is close. It was 5. Sorry, guy. So they said, the developer said, well, when we use 5 blockchains, and all of these blockchains had over dozens of nodes, we are more secure. So they used IOTA, the public Ethereum network, GAF Digital, Max Planck blockchain, and another one. So they said, well, everything we have in our database, the hash of the database, is put into these 5 blockchains. So I have super redundancy here when I want to query the blockchain. But what they forgot is the verifier is not talking to the blockchain. It's talking to their database. And there's only one database. So when this database is not available, the blockchain redundancy is useless. But this wasn't the biggest part, because normally when you get injected, you normally get the vaccine by needle. There was another one, a code injection, because you had the credential at the QR code, and some guys at Golem found out, well, when I add some characters at the end, I can manipulate the input fields and show, well, this credential was valid. Sorry, Hubert. And IBM, also, this was the first fail in Germany. Next one. So some months later, they say, well, okay, we have the Corona Pass, which works fine without blockchain because there was no real use case for it. We need driver licenses, the mobile driver license on the smartphone. You cannot use it by the law when you get controlled by the police, but they said, well, at least you have it on the smartphone and you can use it when you want to rent a car X6. So it's okay. And then this wonderful person here said, okay, I want to use blockchain. And I think 3 days before the election last year, he went in front of the cameras and said, well, now you can use it. Okay, what happened? How should it work? Well, when you need to present the credential, you normally scan the QR code. We saw it in the demo in the morning. With your smartphone, you scan the QR code and you see okay, with whom you will share your data. You can accept it, you can deny it. This is the good part. Because when you decode the QR code, it's just base encoding. You see, okay, here are some informations. Okay, here I'm seeing a label with whom I'm talking. Then I see some images, and I see a URL here, which with the backend I have to communicate with, which I will share my data. The problem now is when you look at the encoding, it looks like a JSON Web Token, but it's just the body, it's no signature. So there was no problem for hackers to say, well, when the code.talks conference has a QR code here, there hanging, I'm going to them, replace the information, and they are not talking with the backend of about you, but with my backend, and they think they are sharing the data with about you. So there was no validation with the person I'm sharing the data. Not the best way. So according to this, also some technical scaling problems come up because they tried to run it as a test development. And the minister thought, well, I have to collect votes. So I say, well, now it's production. And the developer team didn't know about it. So everything crashed after 4 hours or so. So you opened the download the app, and you waited 10 minutes, the loading screen, and then the app crashed. So, and then there were some other problems. For example, beside the validator verification, the low-key instances they used for monitoring the logs had no authorization. That means you can load everything into the logs. It's not a security issue so big, but it's not the best way. And there were some bad DNS configurations, which could have allowed you to get control over the domains. So they shut it down. The app was removed from the App Store with 1 star. And they said, well, we only need 5 weeks or so to fix it. Still offline. But that's not all. In the meantime, some guys, including me, looked at the used source code. And we found some security vulnerabilities that you don't want to have in your blockchain. For example, when you're using a blockchain, you say, okay, I have redundancy, so I can process more requests because I have hundreds of nodes, and all the nodes can handle more. The problem now with the used solution was the limit of the connection was set to 500 because they used 0MQ as a protocol, and the developer said, well, we made some tests, and we saw there's a risk of memory overflow. Let's set the limit to 500. Which is okay for the normal use case, because normally you just need about 50 milliseconds to request the node, you get the information, and you close the connection. But reading this in the documentation, a hacker thinks, well, I opened 500 connections and let them open the whole time. So nobody else was able to query the blockchain. And then we have the other part. Some of you maybe heard about the merge from Ethereum, where they changed from proof of work to proof of stake. And it was a manual update process, so a lot of validators have to migrate manually, so starting the software. And the developers thought in this blockchain, well, let's do it the automatic way, so the software is updating itself. You push a transaction into the system and say, well, we want to update on version 2 at 2 in the morning, and then all the nodes will handle this by own, so no human interaction is needed. The problem in the implementation was that the command was first executed and then was validated, is the person authorized to do this? So you could write into the version number some shell script, because it was directly passed to the shell, something like delete everything. And this command was executed on all servers simultaneously, and then the server said, oh, okay, the person was not authorized to do this, but everything is lost. Or you could install a backdoor, even worse. But to disappoint you, all these vulnerabilities are already fixed. I'm not sure, to be honest, if everyone has updated their systems. Okay, so last but not least, Germany said, well, digital certificates for our students, blockchain. Why not? So the Bundesdruckerei that is controlling the PKI said, well, okay, we have this law when you're giving out a credential in the government's part, it has to be a handwritten signature. And the law says, well, you can do it the digital way, but you need a qualified signature. So you have the easy signature, the advanced signature, and the qualified. And normally the qualified has very high regulations with identification. You get a trusted service, qualified trusted service provider, like Swisscom, Dtrust, etc. And they will give you a qualified signature that is applied to the law. And the problem was, well, blockchain is not on this level. So they said, well, we're using a PDF, adding XML in it, because we need machine-readable data, putting a qualified signature on this, generating a hash from it, and putting it in the blockchain. And then everyone asked, well, why are you using the blockchain? Because the real truth, the manipulation protection, comes from the qualified signature, not from the blockchain. So they said, well, we do it. Well, we use a permissioned Ethereum network. We have some data centers spinning up a network where only authorized persons are allowed to write. It's okay. Then they said, well, we have authentication rules in the smart contract. So normally when you're defining a contract, you have program code, and you can, for example, say, okay, from these sender addresses, I'm accepting new entries. You have a list of hashes, and all these hashes are from the credentials you have given out. Fine until now. And in the Ethereum world, normally you need gas to run the smart contracts. Now, these gas you get by token, but when you're performing consortium network, you don't really need this kind of incentive. So I said, well, okay, we need some kind of endpoint that our application gets the gas. But they forgot to set the password for it. So some guys found out, well, cool, I'm not able to write into the deployed smart contract to hijack the system, but I can get the tokens to deploy my own smart contract and write everything on the ledger I want. And the problem when you offer something as a service, like infrastructure or blockchain, software as a service, you are a data processor. And there are some conflicts like GDPR or STGB that you are responsible for the contract. For example, when you are a data provider and somebody is uploading personal data or child pornography or illegal content, the law will say, okay, please delete the data. And you say, well, I have a blockchain. A blockchain cannot delete. They say, well, I don't care about the technology you are using because the law is technology independent. You have to delete it. Well, so the whole thing went down again. So all these actions from going live to going down was about 2 days for all these scenarios. And the development in front was more than half a year, so they had plenty of time to battle test all the things. And of course, cross-site scripting was enabled. They had an endpoint, normally, where you pass an Ethereum address and get information, okay, in which block this is. But when the Ethereum address was not found, they just gave the input back. Who of you thinks, what is a good protection against this? What technique could be used to avoid cross-site scripting? Yes? One example, sanitize the input. Well, they added something, some kind of protection. This little guy. We don't know. It was there for about an hour or so. Then they removed it, but you get no answer when you ask the Bundesdruckerei why they had this beautiful animal on their servers. So for you, normally we have, when you need a new animal, this is free to go. It's not an NFT yet. Maybe, Stefan, you can claim it. Okay. Okay, so what are the learnings? What can you learn from the mistakes the government has made with your tax money when you are living in Germany? Don't publish your test environment to production. So all the URL we saw was publicly available. So, and the problem was for the hackers that they could write their article and bashing against the Bundesdruckerei that nowhere in the system was mentioned that this is a test system. Normally you would just say, okay, I deployed in an intranet or I'm putting a firewall in front of it, but they made it public available. Okay. The next question is, okay, do I really need blockchain in this scenario? When we are going back to the COVID certificates, we say, well, they are storing the database hash in the blockchain. And they said, well, we are only using the database hash because of the transaction fees. When we put everything in the blockchain, it's so expensive. But where's the benefit if you still have the single point of failure inside it? Just use one blockchain or use any other system like a qualified signature, which cost about €1 or so. So the amount of paying was the same. And understand what you're using. So when your manager comes to you and says, I want blockchain, I really want it. The PR agent department has already made the sheets, etc., that we are using this technology. And when you went over the sites where they described the use case, blockchain was in every sentence. But they never mentioned how they used it. They just claimed, okay, blockchain, make it secure, but there was no technical description that said, well, what is written to the blockchain? There was no kind of external evaluation. What are the pros and the cons of it? There were some in the project. There's a site called Frag den Staat. And some hacker called Liz Wittmann asked, well, let's see if there were some internal security audits. And the problem with the bypass when not validating the verifier was already known. So to the public, it seems very strange that the security vulnerability, a very big one, because we are talking about I'm in control with whom I'm sharing the data, but how can I be sure with whom I'm sharing the data? And the whole topic is under development. So right now we have different crises, and in Germany especially we want to have the level of risk very low. So when you want to start a project and don't want to run into unexpected difficulties, you should use bulletproof technology. And for all the cases we saw here, we could use legacy software. It doesn't really sound great when you use legacy software to the hipsters out there or to some venture capitalist, but they will save you a lot of reputation and money in the middle and long run. So, is the subject dead? Not yet. Maybe, we don't know. With the consortium, we started with TrustCerts and other companies. We founded a European, in Germany it's called consortium. So we want to run a blockchain network in Europe as a verifiable data registry as a service. So on the one hand, it's a company with whom you can make contracts. So, for example, for service level agreements, etc. But the whole construct is decentralized and distributed. So you don't have to be afraid if one of the members, let's say, okay, we have the ENG, and in 2 years they say, well, we are leaving the consortium. So no data will be lost because all other members of it already have the data, and you have a strict government so that there is no majority, not one company that is able to control the way of the company. And what is very important for us is that we are not going one way that we say it's only this technology stack and everybody has to adopt it. We are spending a lot of time into interoperability. That means a lot of companies are in different standardization groups, like Hyperledger areas, where we say, well, in the end, we have this blockchain that can be used, or this verifiable data registry, but your use case should be compatible with other systems. So, for example, you have a credential, and some informations, like the public key, is stored in this verifiable data registry. The revocation list you are using is hosted on another service, but everything is using the same protocols and interacts together. Yes. That's was it. I think there are more failed projects right now, but I hope you could learn something from it and make it better. Thank you.